Hello everyone, welcome to my channel Nerdy Coder. If you're the first time seeing my video, please give me a like and subscribe and share this video with others. This will give me more motivation to create new videos for you. In this video, I will refactor a REST API using MVC Pattern and object-oriented programming with Node.js, Express.js and TypeScript. MVC stands for Model View Controller. It is a design pattern which helps you write more modular code and adopt separation of concern. By using MVC pattern in your software design, you'll be able to solve complex problems with simpler and smaller components. In my other video, I explained the concept of MVC and how it could apply to a REST API. We consider the API contract of our REST API as the view of MVC. We use OpenAPI document and data validation to enforce the API contract. When a client sends a valid request according to the API contract, it will tell them exactly the format of the response. This video will focus on the model and controller of the MVC pattern, as well as the data access layer. I'll be creating domain object to handle business logic. I will use data access object to persist and retrieve domain object from the data layer. I will also create data mappers to convert between data transfer object and domain object. The controller will be used to coordinate the workflow in each endpoint. I will use object-oriented programming to implement the MVC pattern. Object-oriented programming allows us to abstract away the implementation details and let us use various design patterns such as dependency injection. This is going to make our code more maintainable. If you want to understand the concept of MVC pattern in more details, please check out my other video. Before I begin, I will first do a quick walkthrough of the code we are working with today. This is a simple calculator API created with Node.js and Express.js and TypeScript. It has two major routes, a health route to get the health status, and a calculator route to get and perform calculations. Inside the health route, it has a getHealth endpoint to return a status of OK and a timestamp. Inside the calculator route, it has some mock calculation data and 5 calculation endpoints. The getAllCalculations return the mock data. The getCalculation by ID using the mock data. Delete a calculation, update a calculation, and create a new calculation. All the business logic is currently contained in this one page of code. You will also see that we have fragments of OpenAPI document in the JS.doc command, as well as in separate YAML files. This is the API definitions for OpenAPI document. These are all calculator components, including schemas, request bodies, and parameters. This is the health endpoints schemas. And these are the components for all error responses. We use a library called Swagger.js to convert fragments of OpenAPI document into a complete OpenAPI document, and save this document as openapi.json files under the schemas folder. We then use another library called OpenAPI TypeScript to generate TypeScript types from this OpenAPI document, and save all the type information as index.t.ts file, also under the schemas folder. Using this file, we extract the types for all data transfer objects we need in our calculator API. We have the type information for the calculator command DTO and calculator result DTO. The calculator command DTO consists of the operator, which could be plus, minus, multiply, or divide, and 2 operands of numbers. The calculator result DTO contains everything under calculator command DTO, plus an ID, result, message, and timestamp. We also have type for error DTO and type for health response DTO. Using the OpenAPI document, we also added automatic data validation to all API requests and responses with the library Express OpenAPI Validator. We created an OpenAPI Validator and added it as an Express.js middleware. We also added a route under /API docs to serve the Swagger UI using OpenAPI document and the library Swagger UI Express. This allows users to read and test our API from a user-friendly UI. All of these form a very solid API contract for our calculator API. If you want to learn more about how to create a solid API contract, please check out my last video on OpenAPI, Swagger UI, and data validation. To refactor the API with MVC Pattern, I will start with creating the domain object, which will be the core of our application. This domain object will be a calculator class. I will create a folder named Models and put this calculator class in this folder. This domain object doesn't need to know anything about Express, the request, response, or anything about data persistence. You can design the class however you like. Here's what I'm going to do. The constructor will take 3 arguments. The first argument is a calculator command. The second argument is a result if you already have the result for the calculator retrieved from a database. This is optional. And the last argument is any metadata about the calculation, which is also optional. This public keyword in the argument means that we are going to take this argument and assign it to a public property called command. This is a short form for this. I'm going to stick with the short form. We're going to create the types for these variables. We have a type for calculator command. The calculator command looks a lot like the calculator command DTO. They could be the same, but they don't have to be. I'm going to make them a little bit different. The operator will be an enum. The calculator result will have 2 optional properties, a value and message. Sometimes the calculation has no result value. For example, if it is a division by 0. The metadata will include an ID and a timestamp. Now going back to the calculator class. I will create a private method called execute. This execute method will create a calculator result. If the result already exists, I will simply return. Otherwise, I will calculate the result. The logic is very similar to the logic we have in the router. I'm going to copy from there and modify it here. I will also create a method to validate the result. Although we have automatic data validation from OpenAPI Validator, it can only perform field-level validation. In this case, we want to make sure that the results have either a value or a message. They cannot both be empty at the same time. Since this calculator doesn't do much else except calculating the result, I will simply calculate and validate the result in the constructor. Before I finish it up, I will also add a method to update the calculation given a new command. We will need this for our update calculation endpoint. If I have multiple calculators with each performing different kinds of calculations, I will create a calculator interface with multiple implementations. Other objects will interact with the calculator only through its interface. I will keep it simple in our case and have only one calculator class. This completes our domain object. We will then create a data access object. The data access object is responsible for saving and retrieving domain object to and from a data store. We could use different databases for our API, such as MongoDB, MySQL database, or other types of databases. We wanted to abstract away the data persistence from the rest of the API, so we will first create an interface for the calculator DAO. I put it under a DAO folder with a subfolder of calculator. This calculator DAO, we have a few methods. The create method will take a calculator object, create a new entry in the database, and then return a saved calculator object. All database operations are likely asynchronous, so we return a promise instead. We have a read method to get a calculator object by ID. This could return undefined if the object with the ID does not exist. an upsert method to update or insert a calculator object by ID, a delete method to remove a calculator object by ID from the database, and the list method to get all calculations from the database. These are all the methods we need in this calculator DAO. Next, we'll create implementation of this interface. I'm going to create a mock calculator DAO. I will name this class mock calculator DAO. I will quickly generate the stubs for this implementation. We can use however data structure we want to store the calculator object. It doesn't even need to have the same structure as the domain object or the data transfer object. To illustrate this, I'm going to use the shorter field names to represent the calculation data. Each calculation data entity will have a form like this. Since most API operations are by IDs, I'm going to index our mock data by ID as well. Now we have our mock data. We need a few more helper functions. I'll create a private function named toPersistence to convert from a domain object to a format required in a database. If ID is empty, we're going to generate 1. I'm going to create a private function called generateID. I'll create a private counter variable in this mock DAO and increment this variable for every call made to this function. If timestamp is empty, I'll use the current time as the timestamp. I will create a function for that. Besides the toPersistence function, we also need a toDomain function. This function will convert from a database entry into a domain object. We'll create and return a new calculation object. In our case, our calculator object is very simple to create, so we can just use a new operator to create a new object. However, if your domain object is very complex, I would recommend you to use factory pattern to create your domain object. You can see the operator is throwing a type error. In our mock database, the operator is a string of plus, minus, multiply, and divide character. However, the domain object requires an enum. To make the conversion, we can create a mapping manually like this. However, if you make changes to your enum, you have to remember to update your mapping here. There's a way to do it automatically. You can get an array of all enum values with object.values. And then we'll convert the array into a mapping using the reduce function. The result will be a mapping which we need. Now we have the toPersistence and toDomain functions completed. We'll implement the rest of the mock calculator DAO. In the create function, we'll first get the persistence object from a calculator object, and then add an entry to the mock database, and then convert the persistence object back to the domain object and return it. The read function is simple. We'll get the calculation by ID and then convert it to a domain object and return it if the calculation exists. Otherwise, return undefined. The observe function is similar to the create function, except that we'll assign a new timestamp for this update. The delete function will delete the calculation, it returns nothing. The list function will convert all calculations in the database to a list of domain objects and return it. This completes the mock calculator DAO implementation. Next, before we implement the controllers, we will first implement the data mappers. Data mappers convert between data transfer objects and domain objects. We have two data transfer objects for calculators, the calculator result DTO and calculator command DTO. The calculator command DTO maps to the calculator command object. The calculator command object is a value object which is used by the calculator domain object. The calculator result DTO maps to the calculator domain object. We'll create these two data mappers in the folder named Mappers. We'll first create a calculator command data mapper. In this data mapper, we need two methods. The first one is toDomain to convert a DTO into a domain object. Calculator command is a value object instead of a domain object. I will keep this naming convention. In the calculator command value object, the operator is an enum. We perform the same mapping as we do in the data access object. Then we add a toDTO method to convert from the calculator command value object to a DTO. We will then create a calculator data mapper. There's currently no use case of converting a calculator result DTO to a calculator domain object. In our calculator API endpoints, none of them requires the client to send the calculator result back to the API. So we don't have the toDomain method. We only have the toDTO method. The domain object has three properties: command, result, and metadata. Metadata and result must not be empty because they are required in the DTO. We will do a quick validation here. And then we'll convert to a calculator result DTO. We'll use the calculator command mapper to convert the calculator command value object to the calculator command portion of the calculator result DTO. This completes the data mapper's implementation. We have all the building blocks ready, and we will now implement the controllers. The calculator controller will connect all the pieces together for each of the 5 calculator endpoints. We will put the calculator controller in the folder named Controllers. The calculator controller constructor takes one argument, which is a calculator DAO. This is the interface for calculator DAO, but not the mock calculator DAO implementation. The controller does not need to know how data persistence is implemented. The first method is to get all calculations. It will return an array of calculated results DTO. I will get all calculations from the DAO and then map them to an array of DTOs. Next is the get calculation by ID method. This will take an ID and then returns the calculated result DTO. I will first check if the calculation exists. If not, I will throw an error. Otherwise, I will convert the result to a DTO. Then, I will implement the delete calculation by ID method. It takes an ID but does not return anything. Again, I will first check if the calculation exists. If not, I will throw an error. Otherwise, I will delete the calculation from the database. You may realize that the code to get calculation by ID and then throw error is repeated. We can move this code into a separate method to reduce repetition. I will create a private method called getCalculation or throwError. And then update the getCalculation by ID and delete calculation by ID to use this private method. Next, we'll implement the update calculation method. This takes an ID, a calculator command DTO, and then return a calculator result DTO. I need to first check if the calculation exists. If not, I will throw an error. I can use the pirate method we just created. Then I will call the update method of the calculator domain object to update the calculation. It takes a calculator command value object. I made the conversion using the calculator command mapper. Then I will update the record in the database. And then return the updated calculation in a DTO format. Lastly, I will implement the create calculation method. It takes a calculator command DTO and returns a calculator result DTO. I will create a new calculation with the domain object. Then save it in the database and return the saved calculation. This completes the calculator controller implementation. Lastly, I will update the calculator router. I will actually convert the Express router using object-oriented programming. This will allow me to use design patterns possible for object-oriented programming in future evolutions. I will create a class named CalculatorRouter. Constructor will take one argument, which is the calculator controller. Inside the constructor, I will create a router. I will create private methods to add each of the 5 calculator endpoints to the router. First is for the getAllCalculations endpoint. This will simply return the result from the calculator controller's getAllCalculations method. Next is for the getCalculationById endpoint. This will return the result from the calculator controller's getCalculationById method. Then I will add one for the deleteCalculationById endpoint. This will simply execute the calculator controller's deleteCalculationById method, and then return a status code of 204 with no response content. And then the update calculation endpoint. I will return the result of the calculator's controller's update calculation method. Finally, for the create calculation endpoint, this will return a status code of 201 and return the result of the calculator's controller's create calculation method. We then call these private functions in the constructor. I also add a property name base path of /calculator in this calculator router class. This base path should also match with the path defined in an OpenAPI document. I will also clean up and remove the mock data on this page of code. Now, I will go back to the file app.ts and update the Express application to use this new calculator router. I will need to create a calculator DAO, which is based on the mock calculator DAO. Create a controller using the calculator DAO. Then create a calculator router using the calculator controller. And finally, update the calculator router using the calculator router object. Now, we are ready to start up our Express server and test all the calculator endpoints. Everything works, which is good. However, there's one issue. If we try to delete a calculation which doesn't exist, it should throw a not found error, and the API should return a 404 error. However, the entire Express.js app crashed instead, and it seems our error handler is unable to handle the errors properly. This is because for Express.js version 4, the error handler is only able to capture the exceptions thrown from synchronous functions, but our request handler functions are asynchronous. Let's go back to our calculator router and see how we can fix it. Our request handler has only request and response, but there's actually a third argument called next. This is a next function similar to the next function in the middleware. To trigger the error handler, we need to call the next function with the error object. If your request handler is synchronous, Express.js will do this automatically when an exception is thrown. But for asynchronous function, this does not happen automatically. There are a couple ways to fix it. Upgrade to Express version 5. In Express version 5, it will call the error handler automatically even in asynchronous functions. However, version 5 is currently in beta at the time of this video is made. If you're building Express API for a production system, you shouldn't use libraries which are in beta. You can also manually capture the error using a try-catch block and call the next function when an error is thrown, like so. We can try to delete calculation again, and now it's working as expected. However, adding a try-catch block to every asynchronous request handler could be quite repetitive and tedious if you have a lot of endpoints. Another way to fix it is to create a wrapper function. This wrapper function will take a function as an argument. This function is our request handler function. This wrapper will return a modified request handler function. Inside this new request handler, we wrap the function call in a try-catch block. If you don't want to write your own wrapper function, you can use a library called Express Async Handler. This library exposes a wrapper function. But there's even a simpler way to fix this. There's a library called Express Async Errors. All you need to do is to import this library in app.ts. This library will patch the Express.js library so that it can handle exceptions thrown from asynchronous request handler. And you don't have to make any changes or use any wrapper. I will first revert my changes in the calculator router and install this library. In app.ts, I will import Express Async Errors and then test the delete calculation by ID endpoint again. And it's working. We have successfully refactored the calculator API using MVC Pattern. We created the domain object, data access object, data mappers, controllers, and the updated calculator router. You may have realized the amount of code that we wrote have increased quite significantly compared to what we originally had. But you have also achieved great separation of concern. Each of these components have its own specific responsibility. If you want to update your database, you know where to change the code without impacting other components. If you want to update your calculation logic, you know where to make changes without impacting existing functionalities. Separation of concern is very important if you are creating large and complex applications, and it's very helpful for future evolution and maintenance. This is also a trade-off you need to make. If you're only making very simple API, a health check endpoint, and this API will never grow bigger and the backend database will never change, then it may not make sense to invest time upfront to apply MVC pattern to your API. I would encourage you to learn MVC pattern and other architectural patterns so that you can apply the best patterns or no patterns at all for what you are making. This is the video I wanted to share with you today. If you like this video and find this video helpful, please give me a like and subscribe and share this video with others. This will give me more motivation to create new videos for you. Thank you for your support. Goodbye and see you in the next video.